Okay, Assalamualaikum and good afternoon. Okay, let's start the class. Can hear me?
Yes.
Can, doctor.
Okay. So first, it is about your quiz 4. As I mentioned, it will be next week on Monday lah, as usual. Okay, we start at 12 and we finish about 12:50 lah. Okay, so as usual, the quiz 4 is about 4.2, what we call the one-way ANOVA. Okay, only the one-way ANOVA method. Okay, so that's your quiz 4, and there is no virtual class next week. Okay, so I will be on leave next week. So there is no virtual class for the next week. So you just study by your own the subtopic for next week. Okay, so then after that, a week after that, inshallah we will what we call discuss lah. What do you, if you have any questions okay, regarding the subtopic for next week. Okay, we will discuss on the next week. Okay, so that's about the class. Okay, so so today it is about chapter 5. Okay, linear regression and correlation. Okay, so the regression, it is about the relationship of two variables and more. Okay, so it is about relationship of two and more variables. Okay, but in that data, okay, the data for the regression, okay, if you have two data, okay, two variables, okay, one of the data, the minimum number of variables for the regression is 2 lah, okay. So your data must be one of the variable is a independent variable and another one variable is a dependent variable. So means that one of the variable must be depends on another one of variable. Then we can discuss the relationship between variables. Okay. So we start with the correlation. So correlation is a simple, what we call simple numerical value that we can calculate in order to know the relationship between variables. Okay. And then we have simple linear regression model. Okay. So simple linear means that you have two variables only. Okay. One independent and another one is a dependent variable. Okay. So means that one variable depends on another one variable. Okay, then you have simple linear regression. Okay, multiple linear regression means that you have more than two variables. Then we are dealing with the multiple linear regression. Okay, so means that for the multiple linear regression, dependent variable still single variable, so satu je dependent variable and the rest of it independent variables. Okay, so means that the dependent variable depends on more than one independent variables. Okay, so independent variable denoted by x, so means that for the multiple linear regression you have more than one x variable. Okay, dependent variable denoted by y. Okay, dependent denoted by y, independent denoted by x. So y always single. Okay, y always single. Okay, for the multiple pun sama, y hanya satu, single variables only represent the y. Okay. The regression that we discuss in this chapter, this is for the quantitative variable. Okay, quantitative variable, only for the quantitative variable. If you have qualitative, okay, which is we not cover in this course, but in future, if you have your own raw data, you have the qualitative variable and then you need to discuss the relationship between variables. Then you can use the advanced regression, which is logistic regression. Okay, just for your information. Okay, if you have qualitative variable, then you are dealing with the logistic variable. Okay, sorry, logistic regression. Okay, logistic regression. We use logistic regression when we have qualitative variable. Okay, what we have in this course, in this chapter, chapter 5, it is about quantitative variables only. Okay, so y quantitative and your x also quantitative variables. Okay. So in this chapter also for simple linear and multiple linear both we have the hypothesis testing lah. Okay, so that hypothesis testing it is about the relationship of variables. We test, okay, we check by using the sample data given, okay, whether in the population they are related to each other or not. Okay, so by using the hypothesis testing. So you have the linearity test here for the simple linear. Okay, and then we have the another one hypothesis for the multiple linear regression analysis. Okay, and what you can expect from this chapter, okay, for that. Okay, what we can expect from this chapter, every single thing, it is not every most, okay, mostly every single thing that you calculate in this chapter, you have to interpret. Okay, there is an interpretation involved for almost, okay, every numerical value that we calculate for this chapter. Okay, so it will be full of the interpretation. Okay, when you calculate the correlation, what does it mean? Okay, when you have the because it is about relationship, then you will have the model that represent your data. Then what does it mean? Okay, the parameter that we estimate, what does it mean? Okay, and then especially for the multiple linear regression, there is no value that we calculate manually. There is no value that we calculate manually. Everything we use the Microsoft Excel. So means that in your final letter for this chapter, we give you the output from Microsoft Excel, especially for the multiple linear regression analysis. Okay, so what we will discuss in this chapter for the multiple linear, we provide you with the output. It will be output from Microsoft Excel. So how to read the output, okay? That value means what, that value represent what, and so on. Okay, for the simple linear regression model, okay, we also have the output. Okay, so when you have the output, you should be able to read the output, what does it mean, and then there is some numerical value that we calculate manually for the simple linear, and in fact almost all the numerical value involved for the simple linear we can calculate manually. It will be manual calculation on that lah. Okay, but still we have the output from Microsoft Excel. So when we give you the output, then you should be able to read your output lah. Okay, that value represent what and what. Okay, that's the introduction. Okay. And then the last subtopic here, we have the model selection. So model selection means that you have a few models. Okay, they could be the simple linear regression models, and also it will be multiple linear regression models. So it will be a mix of simple linear model and also multiple linear model. Okay, so what we do, okay, based on the models that we have, we choose the best model. Okay, we choose the best model based on some characteristic. So we have some characteristic that we use to check, to identify, okay, which one is the best model. So that's what we do for the model selection. So when we have that best model, then we will use that model for the prediction letter. Okay, that's introduction about the chapter 5. Okay, you can interrupt me anytime if you have any question. Okay, so we go to the 5.1, the correlation. Okay, so as I said, correlation, it is about relationship between variables. Okay, it is about relationship between variables. It is a numerical value, a simple numerical value that we can calculate to discuss the relationship between variables. Okay, so we have what we call two different numerical value here that represent relationship. Okay, the first one is a correlation coefficient value and the second one is a coefficient of determination value. Okay, so one thing about the chapter 5, you have to know the terms that we use and also the notation that we use. Okay, for example, correlation coefficient value. Some students, okay, they do not aware about the term, but they know the notation. Okay, correlation coefficient value, it is a small r, the notation that we use. Okay, some students, they know r, but they don't know the correlation coefficient value. So you have to be aware with that. Okay, especially when we go to the assessment, okay, quiz and also final. Okay, we do not use the notation. Okay, what we use is a term in your question. For example, find the correlation coefficient value. So you have to know that it is a R. Okay. For example, find the coefficient of determination value. Okay. Then you have to know what does it mean. Value apa yang you nak calculate. Okay. So notation important, terms also important lah, because in assessment we use the term. Okay, we do not use the notation. In your calculation, yes, we use the notation. Okay. Okay, so introduction about the correlation. Okay, correlation and linear regression. Okay, the relationship between two or more variables. Okay, you have the independent variable, or we call it as a predictor. Okay, regressor. Okay, so notation that we use for the independent, as I mentioned, it is a X. Okay, and then we have dependent variable or response variable. Okay, another terms that we use for the independent variable. Okay, notation that we use is a Y. So means that Y depends on X. Okay, there is no rule to determine which one is a Y, which one is an X. Okay, it is depends on the question itself, and also it will be some keyword lah in that question. Okay, which one depends on which one. Okay. So correlation identify whether the relationship exists or not and quantify the strength of the relationship. Okay, so linear regression express the relationship in the form of equation. Okay, when after we calculate the correlation and exist relationship between the variables, then we can form a equation. Okay, or we can construct an equation or model to represent that variables. Okay, that's we call linear regression. Okay. Okay, so we have the example here. This one. Okay. Okay, so we have number of hour and final marks. Okay, already notified here. Final mark is your Y and number of hour is your X. Okay. So what I mentioned just now, there is no rule said that the first row is a X, the second row is a Y. No, there is no rule about that. Okay. How we identify which one is a X and Y, it is depends on the question itself, and also sometimes it depends on the common sense. Okay, which one? It is based on our experience. Okay, our experience. Okay, which variable should be depends on which variable. Okay. So in this study, the relationship between the number of hours students spend study for an examination and the mark they obtain. Okay, the mark they obtain. So means that this mark obtained after they study. That's why the mark here depends on the number of hours they study. Okay, so in that question, it will be keyword. Is some keyword that so based on that keyword, we will know which one depends on which one. Okay. Student will obtain a better final mark if they spend more time to study, therefore. Okay. What we write here based on the data here. Okay. Because if we see this data, we can see that Y increase when X here increase. Okay, Y also increase. That's why we can say student will obtain a better final mark if they spend more time to study. Okay, to confirm what we apa kita panggil, I forget that word. Okay, to confirm our observation, yes, to confirm our observation here. So what we write here, it is based on our observation that y will be increased when x increase. So to confirm that, that's why we go to the correlation. We calculate the numerical value to confirm that. Okay, so based on here, we say that better final mark because x increase, y increase. So what we can say here, we have positive relationship. Okay, positive relationship. Okay, to confirm that, then we can calculate the numerical value of the correlation. Okay, scatter diagram. So scatter diagram is one of the method that we can use to study or to investigate the relationship between variables. Okay, but what we have here, it is based on the visualization. Okay, so to confirm that, then we calculate the numerical value. Okay, so the first step, you boleh sketch the scatter plot and then you can comment. Okay, you can comment on the scatter plot. So scatter plot, just a simple scatter plot. Okay, it is between your x and also the y. Okay, we plot between x and also the y, and then we can comment on that scatter plot. Okay, so to confirm our observation here, to confirm what we say here, then we have to calculate the numerical value. Okay, that one we discuss after this. Okay, so we have four basic comment or four common comment that we can write about the scatter plot. So first we have positive linear trend, means that x increase, y also increase, then you will have positive linear trend. Okay, the second one, if x increase but y decrease, then you will have negative linear trend. Okay, curvilinear trend means that it is ups and down. Okay, when x increase, y increase and down. So ups and down, then you will have curvilinear trend. Okay, and then you will have another one, your data is scattered, so no trend. Okay, another comment that you can write. Okay, so to confirm the scatter plot, then we calculate the correlation coefficient. Okay, so correlation coefficient must be consistent. I mean, it must be parallel to the scatter plot. If scatter plot you get positive linear trend, then your correlation coefficient also must be positive. So they cannot be contradict to each other. Okay, must be consistent to each other lah. Okay, parallel to each other. Okay, any questions so far? Any questions so far? Okay, so correlation coefficient, also known as a person product moment correlation, another terms that we use. Okay, another terms that we use. Okay, denoted by capital R or rho for the population correlation. So if you have population data, then we use capital R or rho. Okay, but if you have the data, then we use small r. Small r is for sample correlation. Okay, so used to indicate the linear degree of scatter plot. Okay, that's why I said if your scatter plot you have positive, then R also must be positive. Okay, they must be consistent to each other. It cannot be contradict to each other. Okay, so the value of R measure the strength and also direction of linear relationship between variables. Okay, so by using the scatter plot, we cannot determine the strength. Okay, strength means that you have weak or you have moderate relationship or you have the strong relationship. Okay, we cannot determine lah, okay, the weak, moderate or strong. Okay, we just can determine the direction of your relationship, whether it is a positive or whether it is negative. Okay, if when we draw the scatter plot here, okay, we draw this line. This one we call it as a regression line lah. Okay, regression line. Okay, so if your data point here, data point, data point, data point, data point here close to the regression line, then we can get a good sense that we have a strong relationship. But we cannot confirm that. So to confirm that, you have to use the correlation coefficient. Okay, what confirm by using scatter only the direction. We can confirm that whether we have positive or whether we have negative relationship lah. Okay, but to confirm the strength, it is not strong enough if we use the scatter diagram to discuss the strength. But we can get a good sense lah. Okay, whether we have strong, whether we have weak. Okay, if your data point close to the regression line, so means that we have strong relationship. Okay, kalau you punya data point, far from the regression line, so then we have weak relationship. Okay, that's what it means. Okay. Okay, so if you have positive R, then it is a positive relationship. If you have negative R, then you will have negative relationship. Okay, so the R, it is between -1 to the 1. It is a dimensionless. There is no unit represent the R. Okay, correlation is not robust since it is easily affected by the outlier. Anyone? Can you tell me why it is easily affected by the outlier? You should already study about this. Why it is easily affected by the outlier? Therefore, we should always check the scatter plot with R value lah. So if you have the outlier, it will be illustrate in your scatter plot. Okay, as we know, outlier is a data point which is deviate from the rest of the data. Okay, so when you draw your scatter plot, then we can know whether we have the outlier or not. Okay, so correlation coefficient, it is not robust. Okay, easily affected by the outlier. Why? Why easily affected by the outlier? You can relate with what we have discussed in chapter 1. Okay, think about the answer. Okay, after this I will ask you. Sekejap 2 minit. Okay, so why it is affected by the outlier? Anyone? Anyone? Okay. So it is related to what we have discussed in chapter 1, okay, because outlier, when we have the outlier, it will be influence the sum of the data. Okay, it is similar reason why mean, the average affected by the outlier, because when we calculate the mean, it is about the summation of the data. So similar to the out here. Okay, when we calculate the out here, okay, as you can see here, it is about S, 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 Y, Y, and S, S, Y. So it will be here, we calculate for the sum of X, sum of Y. So it will be affected by the outlier if we have outlier in a data set. Okay, because it is about sum of the data. Okay. So the nearer the value of R to the 1 or -1, the closer the point on the scatter plot are to the regression line. Okay. So the one that I mentioned just now lah. Okay. If your data point close to the regression line, so means that your R will be close to the 1 or -1 if you have negative linear trend. Okay. So means that it will be a strong relationship lah. Okay. So how? So this is the calculation. Okay, this is yours lah. Okay, you can watch the video. How do we calculate the R? Okay, so how do we discuss the strength? It is based on this table. Okay, based on the range of value. Okay, so doesn't matter. I mean the sign negative or positive is to know the direction of your relationship, whether we have negative or whether we have positive. Okay, so if negative, then negative relationship. If positive, then positive relationship. Okay, if R equal to 1, then we will have a perfect relationship. Okay, if negative, then perfect negatively correlation or correlated. Okay, if you have 0.7 to the 1, okay, then we will have a strong relationship. Okay, if you have 0.7 to the 0.5, then we have moderate. If we have 0 to the 0.5, then we have a weak. Okay, if you have 0, then we have no correlation between the two variables. Okay, the implication of R equal to 0. Okay, so no correlation between variables, so means that we cannot use the X that we have currently to no correlation between the variables, so means that the current X that we have, not influence the Y. Okay, so if you have your own research, so means that you have to replace with another variable, because it is confirmed that those two variables is not related to each other. So there is no use for us to use that variable for our study. Okay, you have to discard that variable because there is no correlation between that. When R equal to 0, then there is no use for us to construct the model based on that variables. So what we can do, discard that variable and then replace with the new variable, and then you check again whether it will be influence your Y or not. Okay, that's the implication. Okay, so strong relationship means that your X greatly influence your Y. Okay, if you have weak relationship, means that another interpretation that we can say it just what we call just a few information that we can get from that. Okay, so it is okay to replace with another variable. Okay, if you have weak relationship. Okay. Okay, so this is an example that you can study. Okay, we will go to the exercise after this. So we will discuss how to calculate, to get the R and then how to interpret lah. Okay, interpretation is very important lah. Okay, it is not just we get the value, but we need to interpret that value. What does it mean? Okay, so how to interpret the R? Okay, how to interpret the R here? You have to talk about direction and also the strength of your relationship. Okay, these two is very important. Okay, you miss one of that, then you will lose your mark. Okay, so this is how we use the calculator. Okay, I forgot to share the video of the calculator. So after this, I will share to you how to use the calculator, but you can refer to this tab. Okay, how to use the calculator to get all this summation value for your calculation. Okay, so no need to calculate manually this summation value. Okay, no need to calculate manually the summation value here. Okay, you can get directly from your calculator. Okay, but you have to what we call to key in the data lah, and then you can get your summation value. Okay. Okay, then we have the coefficient of determination. Okay, so coefficient of determination, it is R square, denoted by R square. Okay, same formula of your R, but after you get the R, you just square that value, then you will get coefficient of determination. Okay, so coefficient of determination, it is about how much of variance, okay, from Y that can be explained by X. It is about the variation in Y that can be explained by X. Okay, so most of the researcher, they will go to the R square lah, because this is about the variability of your data. So it is more significant to study lah. Okay, so R square, it is about 0 to the 1 only for the simple linear regression. When we go to the multiple linear regression, sometimes you could have negative R square. Okay, that one we discuss later when we go to the multiple. Okay, but for the simple linear regression, it is about 0 to the 1 only. Okay, if your R here equal to negative value, but when we square, let's say negative 0.5, then you square, you will get positive value lah. Okay, so R square positive value. So it is from 0 to the 1. Okay, so we discuss after this how we interpret the coefficient of determination. Okay, any questions so far? Tak ada?
No, madam.
Okay. Okay. Okay, so 5.2, it is about simply. Okay, so the question of coefficient. Okay, the R value, the coefficient also coefficient of determination, we discuss in exercise later. Okay, how we interpret the value. Okay, so simple linear regression model. So by the end of this topic, you should be able to write a mathematical equation that relate dependent and independent variables. Okay, so this model we can construct after we sure that the R is not equal to 0 lah. Okay, if your R equal to 0, there is no use for us to construct the model of our data. Okay, because it will be invalid to use lah, because there is no relationship between the variables. So it will be invalid to use to estimate the value. Okay, when we have the model, then we can use to estimate the value. Okay, so the estimate the value, we call it as a prediction. Okay, to predict the value. Okay. Okay, what is the model? Okay, okay. So this is the general model of simple linear. Okay, general model of simple linear. Okay, so you have Y, the dependent variable. You have beta node, the intercept. You have beta 1, the slope. Okay, if you still remember, dulu kita belajar y mx plus c, similar. Okay, because it is about two variable, x and y. So m slope and c intercept. So similar lah. Okay, dia sama, same idea. Okay, but here in order to discard the error here, because epsilon here is a random error, then we use the fitted model. Okay, by using least square method, okay, we estimate the parameter, then you will have a fitted model. So this is model that we are going to construct lah. Okay, so means that you have to estimate beta node cap, beta 1 cap. So there is two parameters involved for the simple linear regression model, beta node cap and beta 1 cap. Okay, so dalam soalan, if in this question we said that estimate the parameters, then you have to know it is about beta node cap and also beta 1 cap. So beta node still intercept, beta 1 cap still the slope. Okay, so beta node cap the point which the line intercept with the y-axis lah. Okay, if beta node cap equal to 0, so means that your regression line passing through the origin of the y. Okay, so slope means that the amount of increase or decrease of y for each unit increase, okay, of x. Okay, this is how we interpret the beta 1. Okay, so the interpretation we will discuss in the exercise later. Okay, so this is the calculation. Okay, this one I leave it to you how to calculate. Okay, you can watch the video how do we calculate for the beta 1 cap and beta node cap. So after we calculate, it is compulsory to write your model. Okay, so y cap, beta node cap plus beta 1 cap with the x. Okay. Okay, so we have the properties of the simple linear regression. Sekejap, 3 minit because sekejap ya. Okay, so this is the properties of the simple linear regression equation. Okay. So it is a line that best represents the data on the scatter plot that pass through the S bar and Y bar. It is your regression line lah. Okay, a line that minimizes the sum of square distance between the observed value and predicted value. Okay, so it is about Y minus Y cap lah. Okay. Good approximation of the true relationship between two variables. Okay, so when we have the equation or the model here, then we can use to estimate the value, the one that I mentioned just now, or to predict the value. Okay, so you have here y cap equal to beta node cap plus beta 1 cap x. Okay, so once you have this model, you can use this model to predict the y given the x, or to predict the x given the y. So either one. Okay, sometimes you have y in that question, then we can use y to predict the x, or you have x in that question, then we can use the x to predict the Y. Okay, so depends on the question. Okay, so we can use this model for the prediction. So there is two methods for the prediction. One is an interpolation and the second one extrapolation. Okay, so interpolation means that we predict the value within the range of our data. Okay, doesn't matter what we predict, X or Y. So interpolation is we predict the value by using the value within the range of our data. Then we have interpolation. Okay, extrapolation, we predict the value with the value which is outside from the range of our data. Okay, so extrapolation, when you do the extrapolation, the data or the value that you get might be invalid lah. Okay, you will get invalid value. Sometimes you will get negative value, or maybe it will be too outside from the limit of your data, okay, because of the extrapolation. So it is not what we call, we have to avoid the extrapolation method. Okay. So guideline of using simple linear. This is for condition which we cannot use the simple linear regression equation. Okay, so this is for conditions where we cannot use the simple linear regression equation. If there is no linear correlation, means that when R equal to 0, so we cannot use, or there is no use for us to construct the equation and make a prediction. Okay. When using the regression equation for prediction, stay within the scope of available sample data. So means that interpolation. We go to the interpolation, be extra with the extrapolation. Okay, when we do the extrapolation, the result that we get might be invalid. Okay, sometimes negative, sometimes outside from the range that is supposed to be. Okay. The regression equation based on the old data is not necessarily suitable for the current data. So means that, let's say that you want to predict the current situation, we cannot use the equation from like 10 years ago, for example. Okay, the result might be invalid. Okay. Do not make prediction about a population that is different from the population from which the sample data were drawn. So means that, let's say that you construct equation from the data from A, population A. So we cannot use equation from A to predict something from B. Tak boleh. So you have to construct its own model, okay, to predict the population B. Okay. Any questions so far before we go to the exercise? Any questions so far? Okay. Senang ya chapter 5 ni. Okay. A study is conducted to investigate the relationship between cause of fire damage, okay, and the distance between the fire station and the location involved in the fire accident using regression method. Okay, the data is given as follows. Identify the independent and dependent variables. So which one is independent? Which one is the X?
Distance.
Distance, should be distance, not the cause. Okay. Cause of fire damage, okay, depends on the distance between the fire station and location. Okay. So kat sini I said that dia based on common sense lah. Yang mana depends on yang mana. There is no rule to decide. I mean the first row is a X or Y, no. Okay, you have to based on the question, also based on our common sense. Okay, which one depends on which one. So X is a distance. Okay, so cost depends on distance. So cost is a y lah. Okay. So draw a scatter diagram and give comment. Okay, that's yours. Okay. Just okay, in order to draw a scatter diagram, you have to use a proper axis lah, macam kita buat untuk box plot. Okay. So a proper axis, okay, for the x and y. Okay. So the axis depends on the data. Okay, depends on your data how the axis. Okay. It is difference 2 or 5, depends on the data, but it must be proper axis so that we can see the trend clearly. Okay, whether we have positive, whether we have negative and so on. Okay, so must be on proper axis. Kalau tak proper memang tak dapat makan lah. Okay, so proper axis like what we do for the box plot. Okay, so that one is yours. What you get for your, the trend of your scatter diagram? Positive trend. So give comment means that notify what trend that we have. So based on your friend's answer, it should be positive trend. Okay. So C, calculate, no need to calculate manually the sum square value, the summation value here. Just use your calculator. Okay, so you can study the step in the module and also the step in this slide note. Okay, but after this I will share the video lah. Okay, so use your calculator. Do not waste your time to calculate manually. Okay, so similar to the quiz 5 letter. Quiz 5 is about 5.1 if I'm not mistaken. Okay, so do not calculate manually this summation. Okay, just use your calculator. So practice lah. Okay. Calculate the correlation coefficient and interpret its value. So what do you get for your R? Anyone? 0.9541. Okay, 0.9541. Okay, so the rest you can check, interpret its value. Okay, so as I said, almost every numerical value that we calculate, we have to interpret lah. Okay, so R, it is about what we have to measure two things. Okay, it is about direction and also strength. So both must be mentioned in your interpretation. What is the direction here? Apa dia direction dia kat sini? Based on R value here. Anyone? Direction.
Positive linear correlation.
Positive. The strength?
Strong.
Okay, baru strong. Strong is a strength, not direction. Okay, direction is either positive or negative. Strength, it is either strong, weak or moderate. So 0.9, it is between 0.7 to the 1. Okay. So 0.9 here, it is between 0.7 to the 1. So it is strong. Okay. So we have the direction and strength. So there is a strong positive linear relationship between you can mention X first or you can mention the Y first, it's up to you. Cost of fire damage and distance of fire location to fire station. Betul ke? Fire accident to fire. Okay lah, tak apa. Okay, so the distance of the fire accident to the fire station. Okay, any questions so far? So this is how we interpret. Okay, the most important, these two. Mesti ada in your interpretation. Okay, you miss either one, there's no mark for the interpretation. Okay. So calculate the coefficient of determination and interpret its value. So it just R square. Okay, you already have your R. So R square is a 0.9541 square. What do you get? 0.9103. Okay. Coefficient of determination discuss the variation in Y that can be explained by X. So when we interpret the first one, we convert this one into percentage because it is about percentage of variation in Y that can be explained by X. So 9103% of variation in Y. So Y is a cause of fire damage. Can be predicted or can be explained by the distance of fire accident to fire station. Okay, so the most important one, word variation must be there, compulsory, in Y. Okay, so in general, you will have variation in Y that can be explained by the whole thing here, that's your X. Okay, any questions so far? Ada? Okay. Next. Estimate the regression parameters and write the estimated linear regression model. So after you estimate regression parameters means that you have to find beta naught cap and also beta 1 cap. After that, write the model. Okay, you write the model, then you get another mark lah. Okay. Okay, so the F calculation, I leave it to you. Okay, you can watch the video how do we calculate. Okay, I think the most important one here, how we interpret the value lah. Okay, because it is what we call just a simple calculation. Okay. Okay, so what do you get for the beta naught cap? Beta naught cap. Okay. 93983 or 82 can be accepted lah. Okay. Okay, the beta 1 cap. Yang lain, make sure you do the exercise Okay, 5.1817. Okay. So when we write Y cap, so beta naught positive, then write as it is lah. So if negative, then you just put negative. So plus, because we have positive, 5.1817 S. Okay. So E. Give interpretation of regression constant beta naught and regression coefficient beta 1. So I forget to mention just now before this. Okay, beta naught intercept also called as a regression constant. Another terms that we use to represent the beta naught. Okay, regression constant. Okay, another term for the beta 1, the slope is a regression coefficient. So take note Okay, regression constant means that beta naught cap. Regression coefficient means that beta 1 cap. Okay. Okay, so how to interpret the value? So beta naught first. Okay. So when we interpret this value, we let x here equal to 0. Okay. So when when x is held constant or equal to 0, then estimated value of y, the cause of damage of force of the estimated, not value lah, tak payah mention the value, the estimated cost of fire damage is, do we have notation for the y? Do we have notation for the y? Notation pula, unit for the y? When we interpret, you have to state the unit. Do we have unit for the y?
RM.
RM, million, isn't it? So RM 93983 million. Okay, so when X is hard constant, then the estimated cost of the fire damage is RM 93983 million. Okay, ataupun you need to mention the X here lah. So X is a location just now, or the distance. When distance of fire accident to fire station is 0. Okay, and then beta 1. So beta 1 estimate how much y change when x change. Okay, so beta 1 is a positive. Okay. The estimated cost of fire damage, your y, is positive then increase by the value of beta 1 with the unit of y, because the change here is a y. So we have to notify the unit of y lah, by RM 51 million for every x change. For every, do we have unit for the x? What is the unit? km. So for every km of the distance between fire station to fire accident. Okay, if we have negative for the beta 1 cap, then here will be decrease. But no need to mention the negative sign lah. Okay, when reader read your answer here decrease, then we know that we have negative slope. Okay, question so far? Okay. Predict the cost when distance is 10 and predict the distance when cost is 10 million. Okay. So predict the cost, we know that cost is a y. So here predict the y. Predict the distance, we know that distance is a x. So here predict the x. Okay, h. So predict here by using the model that we have, the equation. Okay, of course, when we need to predict something, we have to use the equation lah. Okay, EF. Okay, so we need to predict the cost, which is your y, when given distance is a 10. So you just substitute 10 as your x here. And okay, then you will get, don't forget the unit, million. Okay, FG. G, we need to predict the distance. So distance is your x. Okay. So we need to predict the distance given y. So we need to replace or substitute y here with the 10 million. Okay, 10, right? So when we predict the x automatically, okay, algebra kat sini sikit. So your x, okay, replace y with the 10. So when we predict the x automatically, we need to put cap x your x because we predict the x here. So you will get, and then don't forget the unit km. Any question? Soalan? And sometimes you have to comment whether the answer that you have here valuable or not. So it depends on the value. If the value that you get here is too far from the range of the data, then you can say it is not valuable. Okay, or maybe you get negative value, then you can say that it is not valuable. Let's say that x here you get negative, so it is not valuable because for the kilometer, for the distance, there is no negative value. So depends on the value that you get. Okay, and remember that this prediction we cannot use for another population. For example, that the question is, can we use this, let's say that the data is in Pahang, for example. So let's say that we ask you, can we use this equation for Johor? Okay, boleh ke tak sebenarnya? Boleh ke tak? I ask you ni, boleh ke tak? Can we use this equation for Johor? To predict the, tak boleh. Why? Kenapa? Reason dia kenapa? Because different population. So because Pahang, Johor, different population lah. Okay, because of different population. So back to the guideline just now, guideline of using the regression. Okay, any questions so far?
No, doctor.
Okay, so as I said, there is no virtual class next week. It's just your quiz on Monday. Okay, so quiz is about one way ANOVA, and then you just study, you will study the subtopic for next week by your own. Okay, anything you can ask me for the next during the class for the next 2 weeks lah. Okay, so happy holiday, Merry Christmas. Okay, Happy New Year sekali. Okay, so that's all for today. See you the next 2 weeks, insyaAllah. Thank you.
Thank you, doctor.
Thank you, madam.
Thank you, madam.
Okay.
Thank you, doctor.
Thank you, doctor. Okay.